Okay, now we're going to talk about 13SJ, area under a curve, and area between two curves. So far, we've learned about finding the area under a curve, like this space right here, right? There's a curve, and if we start at A and end at B, we have our integral. It's beginning at A, ending at B, and we've got our function, f of x. Right? So, so just as a warm-up, we've got our function y equals 2x, and and we're integrating between 0 and 4. So if we're going to use geometry, you could say, okay, well, here, from 0 to 4, the area of a triangle is 1/2 base times height, right? 1/2 base times height. My base is 4, because from 0 to 4, that's 4. And the height here, it looks like it's 8. So if I find the area of that, that's 1/2 4 times 8, and we get an area of 16 using geometry. Okay, now if we're going to use integration, we have to take the derivative, the antiderivative of 2x, which is going to be x squared. Remember, the power increases by 1, so that instead of x to the power of 1, it becomes x squared. And then we have to have 1/2 be the coefficient, because it has to be the reciprocal of this. So the reciprocal of 2 is 1/2, and 1/2 times 2 is going to give me x squared. And you'd always double check, is the derivative of x squared, this would be 2x. So the antiderivative of 2x is x squared. Okay, so we're going to do the antiderivative with 4 in place of x minus the antiderivative with 0 in place of x. So if I plug in 4 in for x, we end up with 4 squared, minus if I plug in 0 in for x, we end up with 0 squared, and we get 16. And notice the answers are the same, whether we use integration or geometry. Okay, so that's a pretty good warm-up. So we're also going to do this as a warm-up. So we want to find the area under the curve x squared plus 1. Okay, so if that's my function, to write this in integration form, we write it x squared plus 1 in here. That's my function. And we're going from starting at 1, ending at 2. So we have to put our lower bound and our upper bound there. So if my function is x squared plus 1, I need to take the antiderivative of x squared, which would give me 1/3 x cubed, and the antiderivative of 1 gives me x. And so here I can write it in this format. Now, this is a long line. There was somebody in a previous class that says, oh, is that the number 1? No, this is a long line that represents, here's our antiderivative, and our lower bound and our upper bound. Okay. So if I plug in place of x, I end up with 1/3 times 2 cubed plus 2, minus, and we plug in 1 in for x, so 1/3 times 1 cubed plus 1. And then we end up with 8/3 plus 2 minus 1/3 minus 1, which simplifies to 10/3. You may pause if you need to. Okay, next page. Okay, so now we're going to talk about area between two curves. So if I figure out the area, so between A and between B, if I figured out the area under the under the orange curve, I'd get this whole area under here. And then if I figure out the area under the pink curve, if I subtract the area that's under the pink curve, let's pretend this pink area is the area under the pink curve, then I'm left with the blue area. So if I have the area under the orange curve minus the area under the pink curve, we're left with the area, the blue area. And that's what we're going to be trying to calculate today. So and let's look at our first example. Okay, so in our handout, we've got two equations, y equals x plus 2, and that's my y equals x plus 2 is my orange equation, and y equals x squared plus x minus 2 is my pink equation. And so I first have to decide, okay, which one is on top? The one that's on top is the orange one, which is y equals x plus 2. So I'm putting that function first, because that's on top. And then we're subtracting the function that's underneath, okay, which is x squared plus x minus 2. Now, there was people in the previous period who did not put this in parentheses, and they made a mistake with distributing the minus sign. Okay, so that's something you got to be extra careful of, is distributing this minus sign to each term. Okay, my lower boundary is -2. My upper boundary, the x value, is 2. So we're going from -2 to 2. Okay, so now we want to find this blue shaded area. This function minus this function antiderivative. So before we take the antiderivative, I've got x minus x, that's going to go away. I've got minus x squared, we get this, and then I have 2 minus -2. So minus -2 becomes plus 2, so I have 2 plus 2 is going to give me 4, right? 2 minus -2 is really 2 plus 2, which gives me 4. Okay, so now I'm going to take the antiderivative. So the antiderivative of x squared, power increases by 1, it's going to become x cubed, and then 1/3. And then the antiderivative of 4 is going to become 4x. And we still have our lower boundary and our upper boundary. Our upper boundary is 2. Our lower boundary is -2. Okay. So I plug in 2 in place of x. Then I plug in -2 in place of x. And then it simplifies to -8/3 plus 8 minus 8/3 plus 8. Be careful with the signs here. This is where people struggled with the signs. And we end up with 10 and 2/3. You might want to hit pause if you're confused about the signs. Like this is 8 because I have minus, and then this is 4 times -2, which gives me -8. So minus -8, that's why this is +8. So be careful with the signs. Okay, example 6. Okay, find the total area of this region here. Now, you might think, okay, well, this just starts at -3 and ends at 1. Antiderivative from -3 to 1, at right, the function. No, this is not correct, because notice this area is above the x-axis and this area is below the x-axis. If I do the integral from -3 to 1, it's actually going to give me a negative value for this because it's below the x-axis, and a positive value for this. And so it would give you the net, which would be subtracting this pink part from this part. So what we actually have to do is we need to figure out the area of the blue section, so from -3 to 0. And then we figure out the area from 0 to 1. Now this area from 0 to 1 is going to give me a negative value. So we basically have to subtract the negative value, or we could add the absolute value of it. But anyways, we need to add 2 positive values if we're going to get this area plus the area. Okay, so I want to make sure you guys know how to enter this into the calculator. So if I'm trying to enter this into the calculator, we hit y equals, and then I type in the function x cubed plus 2x squared minus 3x. Right, I got the whole function there. Okay, then I'm going to hit second trace. So it says calculate, and I'm going to arrow down to 7 here. And so it has a little picture of the integral symbol. We're going to take the antiderivative here, enter, and then it's going to draw it. Okay, and now it says lower limit. So my lower limit is -3, so I'm going to type in -3, and then hit enter. And then my upper limit, we're going to 0, right? So I hit 0, enter, and now it tells me this area is 11.25. Okay, and then you do the same thing here, except you do go from, so you, I go 7 there, and then now my lower limit, I'm going to choose 0, enter, and my upper limit, I'm going to choose 1, enter, and now it tells me this little area here is negative 0.583. So you got to be real careful because since it's underneath the x-axis here, just like in this picture, it's going to give me a negative value. So you need to remember that if you're trying to add both the total area, you're going to have to add change the sign there. Okay. All right. Let's talk about this here. So sketch the graph on the same axis. So I've got x squared minus 2x. We graph it and it looks like this, and y equals 3. So like I said just before, you enter it into the calculator if you want to see what it looks like. And so x squared minus 2x and y equals 3. Okay, and we want to find this area here. So you can see the function that's on the top is the orange one. So I'm going to have that function first, and then minus the one that's below, which is x squared minus 2x. So just like we did in our original thing here, we do the top function minus the function that's underneath. Our top function, which is 3, minus the function that's underneath, which is x squared minus 2x. Okay. So, which if I expand this, distribute that negative sign, I get negative x squared plus 2x plus 3. So if I type this into the calculator, so I end up with 3 minus x squared plus 2x. Okay. And I'm going to do second trace. And I'm going to hit 7 to take the antiderivative, enter, draws my graph. My lower bound is -1. Okay, so I type in -1, enter. My upper bound is 3. So I hit 3 and enter, and then it shades it in, and it says the area is 10.66, repeating. Okay, or 10 2/3. Okay. You can use the fundamental theorem of calculus. Here I took the antiderivative, and then I can plug in 3 in place of x. I can plug in -1 in place of x, and then we'll still get the same answer. Okay. So question number 3, I graphed these two equations. Now in this example, the blue line is on top, so I have x minus, why did I wrote this wrong? Oops. X minus 3 And then the orange equation is underneath. It should be x squared minus 3x. So we have to do distributive property with that minus sign. Let's see, did I type this in correctly? This should be minus 3. Oh, let's see if my earlier answer is wrong. Okay, this might be wrong. Let's check it out. So, okay, so x minus negative 3x, it's going to become plus 3x. So x plus 3x is going to give me 4x. I got minus 3 minus x squared. So let's type in this equation. Negative x squared plus 4x minus 3. Okay, I've typed in my equation. Let's graph it. Let's see what it looks like. Okay, and we're going from 0 to 1. Okay, and because it intersects at 0, it intersects at 1. And so second trace, go down to 7, enter. So my lower bound is 0, my upper bound is 1, enter. And it tells me my area is negative 1.33. I need to check this one. This 0.33. Okay, makes sense. It should be negative because it's below the x-axis, but did I type it in correctly? Okay, there may be a follow-up video if this is not correct. Okay, let's do question number 4. Okay, so here we sketched the two graphs, and we want to find they intersect at 0 and they intersect at 1. So we type this into the calculator. We get the square root of x minus x squared. Graph that. And then we get second trace. Take the antiderivative from 0, lower bound, my upper bound is 1, and we end up with 1/3. Okay.